Hello everyone, welcome back to Bytes of CSE on 7-day machine learning challenge on interview questions, and we are on day 5. And the question of the day is, what is the difference between bagging and boosting algorithms? So bagging and boosting are basically types of ensemble methods where instead of using one single model, we combine multiple models to improve the accuracy and reduce the variance. So now let's take a quick overview of how bagging and boosting works. So in bagging, suppose you have this data set. Now you will use bootstrap sampling to cut up this data set into, say, n subsets of your data. Now what is bootstrap sampling? So this is sampling technique where we can choose sample with replacement. That is, the same sample can be selected twice. So what it means is, suppose this particular data, suppose this particular row, and let us assign this as D. So suppose your data subset 1 contains D, your data subset 3 can also contain D. Now each of these subsets will be fed to learners. So these are the weak learners. So there are n learners, so therefore n subsets of data are made. They will be trained in parallel, and after they are trained, when we are to make prediction, we will take the predictions from each of these models, and if the type of the problem is regression, we will average whatever predictions they have made, or if it is a classification type of problem, we will go for the majority to make the final prediction. So definitely this kind of method does improve the accuracy and reduce the variance. Now, sklearn, you don't actually have to frame this type of algorithms. sklearn already comes with lagging classifier and regressor. So since this will not be needed in this particular example, in this particular question, I am not going into the details of it. I will cover these in a different lecture. So now coming to boosting, you have that same data set. Now instead of cutting up the data set, you will be attaching an importance to each data row or each data point. And that is done using weights. You will assign a particular weight to every data sample. Now when you are starting with the process, you will assign the same weight to each of the data points. Now after doing this, you will be feeding this data set entirely to the first learner. The learner trains on this data, and you will evaluate the performance of this learner. Definitely the learner will make some mistakes, and based on the mistakes, like for the misclassified samples or the samples where the error is pretty high, you will increase the weight of those samples. Suppose these samples are misclassified or the error is really high, you will increase these weights. Now after increasing the weight, you will feed this entire data set to the second learner, and the same cycle will continue. The learner will be trained, the performance will be evaluated, and again the mistakes, that is where it misclassifies or where the error is pretty high, those examples will be, the weight for those examples will be increased. And this will continue up till n learners, if you have n learners in your data set, in your ensemble. So first difference that you can see from this particular bagging is the training process happens sequentially in boosting, whereas in bagging it was happening parallelly, right? And now what does this learner do is, each of these learners, it focuses on the weakness of the previous model. It tries to reduce the error made by the previous models. And now based upon the performance of these learners, each learner will be assigned a particular weight. So if the learner has a high accuracy, it will be assigned a higher weight, and if it has a lower accuracy, it will get a lower weight. And based on these weights, the weightage will be added when they make prediction. So a weighted voting or a weighted average will be taken, like weighted voting if it is a classification, and weighted average when this is a regression type of problem, to make the final prediction. So this is also another point where the where bagging and boosting differs. Like bagging, it treated all the learners alike, but in this case of boosting, the learners are also assigned some sort of a priority based on how accurate they were in the training session. And also another important thing is, while in bagging they were training on subsets of data, in boosting these learners train on the entire data set. So obviously there are different flavors to your boosting, like ADA boost, CAT boost, XG boost, and so on. I will be covering these in separately in quick videos. So obviously sklearn has everything. sklearn.ensemble has everything in place. I will be covering these later. Now let's come to the important part, or the main part. You can take a screenshot of this. So here are the differences. When it comes to purpose, bagging reduces variance and prevent overfitting by averaging predictions from multiple models. Whereas in boosting, it can reduce both bias and variance by sequentially improving the weak learners. In case of bagging, when it comes to method, they build multiple independent models in parallel using random subsamples of data, and then they combine their outputs. Here, models are built sequentially, with each new model correcting the errors of the previous ones. So, it emphasizes hard to predict examples, which was not a case in this bagging. When it comes to base learners, models are trained in parallel, whereas in boosting, the models are trained sequentially. When it comes to data sampling, they are trained on different bootstrap sample of the data set, whereas they are trained on the entire data set, and the weights are adjusted to focus on misclassified examples. Here, in case of bagging, the focus is where the base models are all treated equally and independently, whereas since the focus is on hard samples, they really boosting puts the focus on hard samples which were misclassified by the previous models. In case of bagging, it can combine it combines the outputs of base models by either averaging them or taking the majority vote. And in case of boosting, it combines the outputs of base models using weighted sum or weighted voting, where weights depend upon the model's accuracy. In case of impact of weak models, it reduces overfitting by averaging weak models, so all models contribute equally. Whereas in case of boosting, it sequentially strengthens the weak models. Later models have more influence than the earlier ones. In case of variance reduction, it is effective at reducing variance, making it suitable for high variance models like decision trees. And in case of boosting, it can reduce both bias and variance, but it is more prone to overfitting if it is not carefully tuned. When it comes to examples, there can be back decision tree, random forest, bootstrap aggregating, and in case of boosting, you have ADA boost, gradient boosting methods like XG boost, light GBM, CAT boost, and stochastic gradient boosting. Now you can also take a screenshot of this. This talks about the strengths and weaknesses of bagging and boosting separately. So when it comes to bagging strength, it reduces overfitting by averaging independent models. It works well for high variance, low bias models like decision tree. And it is also easy to parallelize, whereas it may not significantly reduce the bias, and it does not prioritize difficult examples. Whereas in boosting, the strengths are it can achieve high accuracy by reducing bias and variance both. It focuses on difficult examples, which improves the performance. And it is also suitable for imbalanced datasets. So what is an imbalanced dataset? Suppose you are given a classification dataset where there are two classes A and B. Now, in your dataset, say 70% of the data is of class A and 30% of the data is of class B, then it is said to be an imbalanced dataset, because ideally both the class representations should be equal. But rarely in real life data set we have that. And then the weaknesses are it is prone to overfitting if the base models are too complex or iterations are too high. And the sequential nature also makes it harder to parallelize, and it is also slower to train. Now, since you have both, I would highly recommend you to frame your own answer, though I have an answer prepared. But you can obviously change it. In both bagging and boosting, we use multiple weak learners. In bagging, we feed random subsamples of data to each learner, where the learners train on bootstrap sample of the data in parallel, and we get the final prediction as an average of the results or as the majority predicts in case of classification type problems. Whereas in boosting, the models work sequentially on the entire dataset and each tries to reduce the error made by the previous ones. The final prediction is aggregated as a weighted average or a weighted voting. So in bagging, all the base models are equally treated, while in boosting, the later models have more influence than the earlier ones. Bagging also treats all the data alike, but in boosting, difficult to predict examples are prioritized by assigning a higher weight to them while training. Bagging works well with high variance, low bias models, while boosting can reduce both bias and variance. So that's all for today, and that goes the final answer. And stay tuned for day 6.